Hey there, welcome back to my channel, and today we're going to continue solving even more fun probability challenges. Stick around till the end because I've got a bonus problem for you so you could practice on your own. And we'll go over the solution in the next episode. Alright, let's jump right in. So here it is, here's our first problem. We have three basic events, and we need to find those probabilities, obviously. So let's start with the A. The A asks us to find a probability for the event A, B, and C. So event A is the probability that our fair six-sided dice will come up with an odd number, and B, that is the prime, and C, the value which is less than 4, 1 until the 4, including 4. So let's try to find the probability of A, B, and C. The probability of the event A is essentially the probability of that 1, 3, or 5. So 3 possible outcomes, which gives us 3 over 6, 1 over 2. This is our final result. And for the event B, we have something a little bit more interesting. This is just prime numbers. Prime numbers is the number which doesn't have any dividers except itself and 1. In our case, we have only 3 prime numbers, which is 2, 3, and 5. So the probability is essentially the dice will come up with 2, 3, or 5. That will be 3 over 6, which is 1 over 2. And the probability of C states that our dice will end up with a number which is less than or equal to 4, which is essentially 4 possible outcomes or 6 total possible outcomes, and 4 outcomes which satisfy our event, or the constraint of our event, which is 2 over 3. And that's it. So in the subproblem B, we have to find the union of events A and B, and we also need to find the probability of their intersection of the event A and event C. In our first case, we have odd numbers, which is 1, 3, and 5, union B, and B, it is the prime number 2, 3, and 5, which would be 1, 2, 3, and 5. That are 4 possible outcomes out of 6 total outcomes, which gives us the probability of A union B equals to 4 over 6, which is 2 over 3. And that's it. For the event A intersection C, we have only 2 possible outcomes, and that's 1 and 3. 2 possible outcomes, which is 1 and 3, over 6 out of possible outcomes, which is 1 over 3. So the probability of the intersection A and C is 1 out of 3. The next thing that our problem includes here is the probability of event B intersection the complementary of event C. The probability of event B intersection the complementary of event C. What would it be? Event B is basically a prime number, which could be 2, 3, or 5, and intersection event C, all the numbers which do not include C. Well, that's basically 5 and 6. That being said, we only have one possible outcome here, which is 5, hence our probability is 1 over 6. Alright, nice work. It's been a pretty simple problem. Let's move on to the next one. So in the next problem, we have a box which contains 6 red, 4 white, and 5 blue balls. And we are drawing 2 balls without replacement. Without replacement means 2 events are dependent on each other. Because if you're already taking one ball out of the box, that would effectively mean that our box contains 1 ball less, which affects our probability. And so we have 6 red balls, 4 white balls, and 5 blue balls. In total, we have 15 possible outcomes. So for the first probability, it asks us to find the probability that 2 balls are the same color. Which kind of scenarios are possible here? The first scenario is that we have red and red in both cases. The second scenario is that we have blue and blue in both cases. And the third possible scenario is that we have white and white. So all we need to do here is just to find the sum of those scenarios. These scenarios are mutually exclusive. That being said, if our scenario A happened, scenario 2 will not happen at the same time. They are mutually exclusive. Thus, the probability of union of those events is just a sum of those probabilities. Now let's try to find the exact probability in the first scenario, a probability that we are going to end up with red balls in both cases. This is the probability of event R1 times the probability of event R2 given R1, because this is a conditional case. And so, that being said, we have 6 over 15 times 5 over 14. In the second case, we have blue and blue, which means we have essentially 5 over 15 times 4 over 14. And in the third case, we have white and white, which is 4 over 15 times 3 over 14. Now we just need to sum them up. This is 30 over 210 plus 20 over 210 plus 12 over 210, which will give us 62 over 210. And reducing this fraction will give us 31 over 105. And the second thing in our problem is that we have to find the probability that at least one ball is blue. This is actually the negation of the event none of them is blue. So the probability of at least one is blue equals to 1 minus none of them is blue. Because in this scenario, we are going to line up with 3 possible outcomes. Either the first one is blue, or the second one is blue, or they are both blue. So let's just find the probability that they are both not blue. That would be equal to the probability that the first one is not blue times the probability the second one is not blue, given the first one is not blue either. So that should be 10 over 15 times 9 over 14. And then we have 3, 5, 2, and 1, 6 over 14, which is 3 over 7. And this is our final result. And consequently, our probability that at least one is blue would be equal to 1 minus 3 over 7, which is 4 over 7. So that's our probability. And as I promised, here's a bonus problem. In a family with 2 children, at least one kid is a girl. So we have to find what is the probability that both kids are actually girls. Try to find the answer yourself and leave them in the comment section below. And we're going to consider this problem in our next episode, so stay tuned.